Hey, everybody. I see we have a few folks coming in. We're going to get started right at the top of the hour here. Phil Crone, the executive officer of the Dallas Builders Association, and we're very excited to have Dr. Jeffrey Kahn with UT Southwestern to talk to us about uh, COVID-19 and where we are and where we're going. So, again, just a couple more minutes and we'll go and get started. Also, for those of you that are coming in, as we go through the presentation today, there will definitely be time for feedback and for questions. You can drop those in the Q&A that I'll be watching along with Misty, or the chat, however you like, and we'll get to those. You can also use the raise hand feature and we'll keep an eye out for that and work it in. I'll put Dr. Kahn's full bio in the chat too, so you can see that and everything he's worked on in a very distinguished career. Okay, it's 10 o'clock and appreciate everybody joining us here. I know we'll have a few others kind of filter in to the Zoom webinar. And again, I'm Phil Crone. I'm the executive officer of the Dallas Builders Association, and really excited to have Dr. Jeffrey Kahn with UT Southwestern here to join us to talk about COVID-19, where we've come from, where we are, and as best as we can determine where we're going with this. Uh, I'll just kind of mention a little bit as we get started. First, I want to thank Dr. Kahn and I's mutual friend, Jeff Dworkin, for being the catalyst for setting up this presentation here. Really appreciate Jeff's passion for the industry as a past president and for setting this up today. I also want to thank our industry investors, Facets, Hotchkiss Insurance, DuPont, Atmos Energy, Fox Energy Specialists, Structure Home Warranty, James Hardy, and BGE. Really appreciate all of our industry investors and what they do for the association. So just again, a little bit about Dr. Kahn. Dr. Jeffrey Kahn is the Director of Pediatric Infectious Disease and Pediatric Infectious Diseases Fellowship Program at UT Southwestern Medical Center and the Director of Infectious Diseases at Children's Medical Center. Dr. Kahn is the Medical Director of Research as well at Children's Medical Center. He received his Bachelor of Science degree in microbiology and immunology from McGill University, received his MD and PhD in microbiology and immunology from State University of New York. And Dr. Kahn completed his internship, residency, and chief residency in pediatrics at Yale University at the Children's Hospital at Yale New Haven, Connecticut Hospital. He stayed on at Yale to complete the training in pediatric infectious disease, and thereafter joined the faculty of Yale University in the Department of Pediatrics and in the Division of Infectious Diseases before joining the faculty at UT Southwestern Medical Center in 2009. I included a link to his full bio in the chat because it has a lot of things in there that I can't pronounce, and I didn't want to have the comedy of me stumbling over those. So without further ado, I'll hand it over to Dr. Jeffrey Kahn. He's going to have a presentation to go over that kind of sets the tone for what we'll talk about this hour. I'll have some follow-up questions, but of course, I want to hear from those of you who have them as well via the chat or the Q&A or raise your hand, we'll get to those as we get to them. So again, Dr. Kahn, thank you for being with us, and we'll hand you the helm.
Well, thank you very much, Mr. Crone, for that generous introduction, and it's a delight to be with you today. So I'm going to go ahead and share my screen. I have a brief presentation. Let's see here. Just let me know. Can you see my screen here?
Yes, we can.
Okay, so I'm going to go ahead and give an update on COVID and SARS-CoV-2, which is the virus that causes COVID, and also discuss some about the vaccine. So first, just to bring everybody up to date, I think we're all sort of familiar with the extent and of the pandemic here. This is a slide that a screenshot that I took yesterday. You can see in the lower left-hand corner yesterday at 1:21 p.m. This is the Johns Hopkins COVID dashboard, and this is a very, very rich dashboard of data related to COVID. And this is the worldview, if you will. And you can see on the left-hand side that we're approaching 100 million cases globally, and this is really quite extraordinary because the virus entered the population probably sometime in late 2019. And we're already close to 100 million cases. You can see the countries are also listed here on the left-hand side, and the United States is number one right now with over 24 million cases. On the right-hand side, you can see global deaths, and again, the United States, we recently passed a very grim milestone of 400,000 deaths due to COVID, and right now, at least as of yesterday, at 403,000 cases. Here is the cumulative number of cases of COVID in the United States. And curiously, the first documented case, as far as the Johns Hopkins website is concerned, was January 22nd. So we're literally at a year. 366 days ago, because of the leap year, was the first documented case, although the first case was probably the first case in the United States was probably January 19th. Nonetheless, we're just about at a year, and you can see this is the cumulative number of cases over time, going from January 22nd all the way to January 19th of this year. I've marked out November 20th, 2020 here, because although the virus has been circulating for an entire year, since November 20th, we've actually doubled the number of cases in the United States. And it really speaks to the acceleration of the pandemic as we move through it. And it seems that acceleration is continuing, although there may be some subtle signs that maybe things are starting to settle down a little bit, and I'll mention that in a moment. So to get a little bit more granular here, this is looking at data from Dallas County and the number of cases from Dallas County. I'll pause here for a moment to let everybody know that on most of these slides, you'll see the website for the information that I'm presenting today. The vast majority of it is publicly available. And I'll be happy to share this slide deck because a lot of these websites are quite dynamic and they're updated, some of them on a daily basis. So if you're interested in looking at this, by all means, check out the website. So anyways, this is the number of cases in Dallas County going from mid-March, actually, to just recently. And you can see that there was a peak of activity in late June and early July. This was probably related to things that were going on during the Memorial Day weekend as far as social gatherings, people maybe letting their guard down with social distancing and mask wearing and so on and so forth. And then there was a lull in activity. And now clearly we're into the second wave of COVID here in Dallas. And if history teaches us anything, it shows that during these pandemics, the second or third or the subsequent waves tend to be more intense than the first wave of infection. In fact, that's what we're seeing here. And you can see these numbers far out or really dwarf the numbers that we had over the summer. In fact, yesterday was the second highest daily count of new COVID cases in Dallas County, second only to, I believe, January 12th. So clearly we're in an accelerated phase right now. Also part of Dallas County website, and again, the link is listed here, is sort of this heat map to where the new cases are being observed. And you can see as of the 18th of January, where most of the hotspots. So you can go back to this and if you'd like to and monitor the pandemic in this way. So just to give you an indication of the impact of COVID in Dallas County, on March 19th, 2020 was the very first death recorded due to COVID-19 in Dallas County. And listed above here are actually the top 15 causes of death in Dallas County: heart disease, cancer, stroke, accidents, so on and so forth. Now, mind you, this is March 19th of last year. As of December 21st, you can see now COVID is now number 3. The number here, this is as of December 21st. This hasn't been updated, but right now we're really pushing close to the 2,000 mark. So this is really extraordinary that a virus that entered our population, at least here in North Texas, a short time ago, has really not only spread throughout the community, but has caused quite a bit of morbidity and mortality. This is, again, another publicly available website. This is produced by my colleagues here at UT Southwestern. And it's a modeling system. And I'll show you some of the data. And this modeling system has really been a guide to how the pandemic is going. And it's actually quite remarkable how accurate the modeling system has been. And again, you can see this was updated just a few days ago with data as of January 15th. And you can see these are the sort of the headlines from the data set, is that hospitalizations for COVID remain at record highs in North Texas. And is certainly consistent with the graph I showed you a moment ago. But interestingly, it says the rate of growth has slowed. Total hospitalizations in Dallas and Tarrant counties are projected to stay flat over the next 2 weeks, but slight increases or decreases are possible. And I've been monitoring this, obviously, since this modeling system has been made available. And it's been a while since I've seen the word decrease in the modeling system. So there maybe is a ray of hope here that maybe we're turning the corner, although you'll see from this slide here that we're still at a pretty high level. So to orient you to this slide, this is COVID hospitalizations in Dallas County, past, present, and future forecasting. The y-axis here is lab confirmed COVID occupied beds. So these are hospitalizations. The red here are ICU beds, and the blue here, non-ICU beds. And this goes from August all the way to the present time. And you can see that there's been a drop in the early fall, and we've been seeing a steady increase. The thing to note about this particular graph is that this blue line is what the model had predicted. And you can see how accurate it is for total hospitalizations and also ICU hospitalizations. And you can see that the line here seems to be leveling off or maybe headed down. So that's very promising. This is the first time I've seen this in a very long time. And so this is the data for Dallas County, and this is Tarrant County. And again, even though that these lines may be leveling off, the most important thing here is to note that we're still at historically high levels, and it's going to be a while before this curve trends down to the levels that we saw several months ago. So we're looking for trends here, but it certainly reminds us that we can't let our guard down at this point in the pandemic. Again, part of the website, they look at the different cities in Dallas County, very much like the data I showed you on the heat map here. The darker blue rectangles show where the virus is. You can see that in most of the cities here, there's a lot of COVID activity, perhaps with the exception of Farmers Branch and maybe Richardson. I'm not so sure whether that's an issue with reporting or testing or whatever, but nonetheless, this is no surprise that the virus is pretty widespread throughout the community. So let me just talk about vaccines here. This is actually a picture, an electron micrograph, one of the first pictures of COVID-19, of SARS-CoV-2. And you can see that this is a very typical picture for the SARS coronavirus. You can see these projections here coming off the virus. These are the spike proteins, and I'll talk about the spike protein in a little bit as we get into the vaccine. So here are the sort of the status of some vaccines. Of course, we all know that the Pfizer vaccine and the Moderna vaccines have been approved through what's called the emergency use authorization by the FDA, and these were approved in December. They both have rely on the same platform, which is called messenger RNA. I'll talk about that in a moment. Here are the ages in the trials. But the extraordinary thing about these vaccines, of course, is that they're really quite effective, at least in the short term. And here are the recommendations for age eligibility for the vaccine. You can see that the Pfizer vaccine was tested in some younger individuals, and that's why the recommendations are for individuals 16 years of age and older, and the Moderna vaccine for 18 years of age and older. Again, these are 2 doses, and for the Pfizer vaccine, it's 21 days between doses, 28 days between doses for the Moderna vaccine. There are other vaccines in production now, going through clinical trials. The only thing that I'll mention about this one is the Johnson & Johnson vaccine. One of perhaps the big benefit of that, it may be only require 1 dose. But again, these are pretty far behind these 2 vaccines. So the rest of the talk, I'm only going to be talking about the mRNA vaccines. So really, what is mRNA? Well, the M stands for messenger. And to sort of conceptualize this, in biochemical terms, mRNA is the first step in the translation of our genes, which are coded in our genome. So if you think about this as DNA sort of being the instruction manual, somebody's got to act on this manual, and then individuals read the manual, act on the manual, and they'll become the messengers, if you will. This, in biochemical terms, this would be the messenger RNA, and of course that leads to the final product. So the important thing to note here is that these vaccines are based on the message. They don't actually interfere with or change the structure of the DNA, very much like this metaphor here, where the messengers really don't change the instruction manual, but they use this instruction manual to lead to the final product. So here is a cartoon that shows us in a bit more of a sort of scientific way. So these vaccines are based on lipid particles. These are microscopic little lipid particles that have messenger RNA that's synthetically produced, that actually encodes the spike protein of the SARS-CoV-2 virus. And these nanoparticles are injected and they're taken up by our cells, and our cells transiently actually produce the spike protein of the SARS coronavirus. This production usually lasts for a couple of days. And what this production allows is for our immune system to see this foreign protein and develop an immune response. And what I can tell you about this is that these nanoparticles are non-infectious. They don't contain any part of the virus. Again, this is a synthetic molecule. I'll talk about the safety profile in a minute, but the safety seems to be quite good. It's got obviously a very simple structure. This is not gene therapy. It will not alter our DNA. And it's a very nimble therapy in the fact that this can be easily modified if the virus changes. We'll talk about variants in a little bit. And this technique or approach is being used for a variety of different approaches, but we'll just talk about COVID-19 now. So a lot of people ask what's inside the vaccine and what's not inside the vaccine. Again, it's all synthetic. No animal products were used in the manufacturing of the vaccines, and no fetal tissue was used in the manufacturing of these vaccines. So this was the first vaccine that was approved, the Pfizer-BioNTech. Again, here's the cartoon that shows what I just showed a moment ago. And you can see that here's the data from the clinical trial. 2 groups of individuals, over 21,000 in each group, and got half of them, 21,000 got the vaccine, 21,000 got a placebo. And you can see here for symptomatic COVID, 162 people developed COVID in the placebo group, only 8 in the vaccine group, and 8 is 95% less than 162. And that's how you get the vaccine efficacy. And again, for severe COVID, it also seems to be protective. So this is what the approval was based on, and it seems to be quite an effective vaccine. Here's very similar for the Moderna vaccine. Again, in the cartoon form here, you could see that the effectiveness is listed here. And again, it's about 94% effective. And here's some graphics that show that the individuals who got the Moderna vaccine seem to be protected against COVID versus people who got placebo. There are side effects from the vaccine, mostly ejection site. There are some systemic effects. In other words, people not feeling well after getting the vaccine, feeling tired, maybe getting a low-grade fever. But other than the allergic reactions, which I'll mention in a moment, most of these side effects are relatively mild. The Moderna vaccine actually had a pretty wide, the vaccine trial had a pretty wide scope. You can see that here that the vaccine was tried in individuals over 65. They were tried in individuals who were at risk for severe COVID. In other words, individuals with underlying risk factors. They looked at a variety of ethnic groups. And you can see here that the vaccine was very, very effective, 94% effective overall. Some of the ranges are a little wide because of small numbers, but nonetheless, it seems among all the categories, this vaccine is quite effective. So there are some safety concerns. Many of you may have heard about this in the news about these allergic reactions. And actually, the CDC published a report back on January 6th looking at this. And you could see here, at least for the Pfizer vaccine, the incidence of this anaphylaxis, this severe allergic reaction, which typically occurs within 15 or 20 minutes after the administration of dose, was actually quite uncommon, 11.1 cases per million doses. So again, this is a very, very small number of cases, although it does occur. And that's the recommendation why after you get the vaccine, you have to wait around 15 minutes to make sure that you didn't have this anaphylactic reaction. Of course, if you've had an allergic reaction to any part of the vaccine, then you shouldn't get a second dose. So that would be what we consider a contraindication. If you've had a history of any immediate allergic reactions to any other vaccine or injectable therapy, this is what we consider a precaution. You can get the vaccine, although you should alert your healthcare provider, your physician, that you've had this reaction. But again, it's a precaution. And of course, if you have allergies against food or pets or venom or environmental allergies or allergies to oral medications, these are neither a contraindication or precaution. You should go ahead and get the vaccine if it's available. Now, there's been a lot of talk about these new variants, and they've caused a lot of concern in the medical and scientific community. The one we're hearing most about is this one from the United Kingdom called the B.1.1.7 lineage. It seemed to have emerged in 2020, September 2020. It's now actually, there was a news report this morning, in 60 countries. It's the predominant strain in England, and actually it's been identified here in Dallas County. And if you look at the map here on the right-hand side, these are the states where this particular variant has been identified. And I think as we do more surveillance, we're going to find out that this virus is widespread. There's another variant from South Africa, it's not yet detected in the United States. These two variants seem to be more easily transmitted, and that's the big concern, although they don't seem to be more associated with more severe disease. There's another variant from Brazil, actually was first detected in Japan, and fourth travels from Brazil. This is, again, not yet detected in the United States. And just the other day, we learned about a variant that seems to have been circulating in California called the Cal 20-C variant. This variant may have been around for a while, but what's striking, and they're having all kinds of troubles with COVID in Southern California. Many of you have heard the news reports, is that half of the samples collected on January 13th are actually this variant. So this is a big concern, whether this variant is going to be causing problems. Of course, the big issue is whether the vaccines will produce immunity that will protect us against these variants. And we don't know the answer to that question yet, although there are preliminary data to suggest that, yes, the vaccine will protect against these variants to the extent of which we don't know right now. But I should mention that these variants, this is expected. These types of viruses, they mutate very easily. It's not unusual for variants to emerge. We know this for the other coronavirus, the common coronaviruses, and other respiratory viruses. So this is one of the wild cards as we move forward is, how are these variants going to impact the extent of the pandemic, and also, how effective our vaccines are going to be. So in conclusion, as I showed, COVID-19 cases continue to rise locally, nationally, regionally. We have these two vaccines which seem to be very, very effective. And these new variants are causing a lot of consternation and concern. We don't know the implications yet for the vaccine. And again, we're going to have to watch this very carefully now. So with that, I'm going to stop sharing my screen, and I'll be happy to address any questions that may come up.
Yeah, thanks, Dr. Kahn. That's a really good overview of where we are, where we're going. I'd maybe pick up right where you left it on the vaccines as it relates to the new variants. You mentioned the mRNA platform, and certainly exciting news on the efficacy front there, and the fact that those can be reconstituted rather quickly to maybe respond to different variants that emerge. But what about the other vaccines that are coming out? AstraZeneca, Johnson and Johnson, Novavax. They use an adenovirus platform, different ways of doing this. What type of things are you looking for in terms of how they may respond to some of the variants, and what particular challenges may they encounter with the evolution of this disease?
Yeah, so I think my first comment for these other platforms, they are, there's a lot of interest in them. They've been used, at least in clinical trials, for other pathogens. Of course, they haven't gone through the type of clinical trial that the two mRNA vaccines have been through. But if we get to the point where we've shown that they are effective, then that's a very interesting question, whether these will be more effective than the existing vaccines. Now, all these vaccines are based on the spike protein of the virus. So they should provide some immunity even against these variants, but we're not going to know the answer to these questions. And of course, the SARS-CoV-2 virus is a moving target. It's going to continue to evolve as things go, as it moves through the population. So it may be that we're going to have to recalibrate these vaccines, or maybe not. And nonetheless, it's very encouraging that we have effective vaccines, and we can possibly get this pandemic under control, at least to some extent. But whether these other vaccines are going to be more effective against these new variants or not, we simply don't know.
Is it safe to assume, though, that we're not talking a all or nothing type of response here? We're talking degrees of efficacy as the virus evolves. It's not going to, at least immediately or anytime soon, arrive at a point where a 95% vaccine goes down below zero, or even perhaps below the 50% bar that was originally set for the target for these. Is that
Yes,
correct?
that's a very important point to bring up. I doubt very seriously that these vaccines will be completely ineffective. Their efficacy may drop, but remember, what's the goal of the vaccine? If the goal of the vaccine is to prevent serious disease, that may be good enough. If you get a mild cold, if that's the worst of it, we've all experienced the common cold. So I suspect that these vaccines, both the existing vaccines and the variants, the existing vaccines and these new vaccines in the pipeline, will continue to have some efficacy, maybe rather robust efficacy against these new variants as they continue to circulate.
That's great. Kind of back to the epidemiology of this virus. It seemed like originally, as we were, and now you mentioned we're kind of in places where we've never been with the epidemiology of this one in particular, but it seemed like most of the thinking back in March or April, or at least a good deal of it, was that this would track like a very bad flu with seasonal waves that would kind of come and go, disappear and appear, but be very significant when they did. And of course, we've seen this be kind of more behaviorally driven, whether it be holiday gatherings or just people coming inside with the weather here being warmer in the summer. And, of course, what we saw up north when it cooled down in the winter. But for most people, they didn't know much about coronaviruses. They were, maybe a fleeting memory from the first SARS back in 2003, or an occasional story about MERS, which is still circulating in the Middle East. So what is the difference, as far as you can tell so far, about this virus compared to the flu pandemics that we're a bit more familiar with? And then also, what distinguishes SARS-CoV-2 from other coronaviruses that in SARS and MERS case are much more deadly, or in the common cold's case, spreads easily but isn't a cause for concern?
So those are really terrific questions. Let's first compare the current SARS-CoV-2, the cause of COVID-19, to the first SARS coronavirus, as you mentioned, first entered the population in 2002, there were about 8,000 cases, a handful of cases in the United States. And of course, MERS, the Middle Eastern Respiratory Syndrome virus, which appeared in 2012, it's still circulating. The difference between these two, between SARS-CoV-2 and the other two, is that it certainly appears that SARS-CoV-2 is a lot more transmissible than these other two viruses. Fortunately, it seems to be less deadly and less lethal than the other two viruses. If there is a silver lining, that's one of them. But it's certainly a lot more infectious and contagious. And, we learned that lesson over and over again. When you think about it, going from a handful of cases less than just a little over a year ago to basically everywhere there are humans now in the world, there's this virus. Why the virus has, is so much more virulent than the sort of common cold coronaviruses, we're just trying to figure that out as well. That remains a bit of a mystery, but I think what it does point to is that there are a lot of these coronaviruses that circulate in animals, and occasionally they jump to humans. And we've now had 3 examples of that. And once we get this SARS coronavirus, this COVID-19 under control, we should be really thinking about the fact that there are other viruses out there lurking, and we should be aware of them and be prepared for the next one that jumps into the human population. As far as the flu pandemics, we've learned a lot from flu pandemics. Of course, the great pandemic of 1918 is the one that stands out. But we all get our flu shot every year, and there is really, really big concern that the flu will mutate, or new strains of flu will develop that will cause another pandemic, very much like what we're experiencing now. For flu, we have a lot more tools in our toolbox. We know how to deal with vaccines with flu. We have antivirals that work very, very well. So I think we're much more better prepared for the next flu pandemic than we were for the next coronavirus that comes along, or certainly for this one that's circulating now.
Great. I may shift back to kind of whether it was foreseeable that we would run into a coronavirus pandemic like we have, but I'm going to go with what the people want here, and we're getting a lot of questions on the immunology front. And obviously this is one of the major unknowns about this virus, is the duration and durability of immunity. And there's been I guess on 2 levels here. I want to talk about the immune response from natural infection and the immune response from these vaccines. And first with the natural infection, there's been a handful of documented reinfections. Of course, our surveillance on that matter is lacking a bit, but it seems like the duration and durability for natural infections seems to last at least several months, perhaps more. What can the early studies of that, which of course will bear themselves out over time, telling you right now as it relates both to natural infection as well as what we hopefully can expect from these various vaccines that at least initially show some good efficacy?
Right. So for natural infection, we know that people who are infected develop an immune response to these viruses. As you mentioned, there are some reports of second infection, although these seem to be uncommon, or I should even say unusual, documented second infection. And I'll pause here for a moment and say that people can shed virus, at least be detected by this PCR test, for quite some time. This is probably not an infectious virus. It's probably just parts of the virus. And so if you test somebody with using this very sensitive test weeks or months later, you may detect the virus. That's not a second infection.
Right.
But there have been certainly documented cases of secondary infection. And the thing to point out is that in those secondary infections, for the most part, are far less severe than the primary infection. So what that is telling me is that even though the immunity to the virus may not be complete, in other words, you still may have a chance of getting reinfected, the immunity is robust enough to protect you against disease. because in these cases of secondary infection, for the most part, somebody was looking for it, or somebody had mild symptoms, or maybe had a fever that maybe had nothing to do with a secondary infection, but prompted somebody to get a nasal swab. So that's very encouraging. And of course, we don't know what the duration or the durability of the vaccine is going to be. We know that at least in the clinical trials, it's at least several months, but these clinical trials are only several months old. So we don't know how long this will last. Clearly, people are looking at that, and hopefully there'll be a long-lasting immunity. There are clues from the seasonal coronaviruses or the common coronaviruses. It seems that immunity from natural infection, because we don't have vaccines against those, that immunity may not be so durable. It may wane over time. That's not the worst thing in the world. If the immunity is for several years, then if we need a booster shot, we get booster shots of flu vaccine every year. So I don't necessarily think that's something to be a major concern. But nonetheless, we're going to find out as we move through this. I'll also mention that it's extraordinary that within a year of a new virus emerging, that we have 2 vaccines. I mean, this is really, really extraordinary. Nobody would have predicted that it would have moved forward so quickly. Unfortunately, this new mRNA technology seems to be working out quite well.
Yeah, not only the speed in which they were developed, but just exceeding, I think, even the most optimistic of expectations on how effective they seem to be.
Mhm.
Another really important part of this return to normal, or however we want to call it, is not just the durability of the immune response from the vaccine or natural infection, but what happens in terms of the vaccinated individuals' ability to spread the virus, even if they're not having symptoms themselves. In my case, I actually had SARS-CoV-2 back in the middle of March, and 10 months later, still pumping out antibodies. So I'm very concerned about, not as concerned about myself, but very concerned about those who I interact with, and I would think so should those who get the vaccine now or may in the future. What's known about that? What do we hope to know? And is there any sort of timeline on maybe when we make those discoveries and we can all get our vaccine and maybe confidently burn our masks at some point in the months to come?
So the 2 vaccine trials that are the basis for the 2 vaccines that are available didn't really specifically address this question. In other words, can a vaccinated individual still get infected and still shed infectious virus? Now, the Moderna vaccine trial touched upon this a little bit, because before the second dose of the vaccine, they actually swabbed individuals. And it seems, based on pretty small numbers, that the vaccine did protect against shedding a virus. The AstraZeneca vaccine that's moving through the pipeline, that vaccine trial actually had individuals swab their nose every week. So we're going to know a lot about the AstraZeneca vaccine as it relates to this specific question. But we don't know the answer. We don't know whether vaccinated individuals can get asymptomatic infection and still spread it. In fact, in the hospital setting, even if you get the vaccine, you're fully vaccinated, you still have to wear a mask. And again, we can't let our guard down, particularly now with the pandemic raging. And I think what's really going to be a challenge for us is that once we get the virus under control, that's when we really, really have to be mindful of keeping the masks and the social distancing and all the other public health measures in place to really squash the virus. But we don't know the answers to that question. So I don't think we're going to have any mask burning parties anytime soon. But nonetheless, we're mindful of the issue that the vaccine may not protect us from sharing virus with others.
Another question on the vaccine front is there any indication or hope that these vaccines may demonstrate some cross immunity to either the common cold or even other coronaviruses that may emerge? I love that there's so much attention to this, and hopefully the funding to make some of these discoveries keeps up. But we've seen the seasonal flu largely be at bay so far this year, as well as in the Southern Hemisphere, who of course have already been through
Mhm.
um, their flu season. So, just overall, as we kind of look at the discoveries that we've made over the last few months, uh, is there some hope that some of these even seasonal iterations of coronavirus and influenza may not be as significant of a public health concern as at least they were years prior?
So I'll sort of take that question and flip it a little bit. The question is whether the vaccine or SARS or COVID-19 will protect us against the other viruses. There are data to suggest that there are some individuals who have protection against COVID or against SARS-CoV-2 who've never been exposed to the virus. And it could be, it's very likely, that exposure to these other common coronaviruses actually may have given those individuals some protection. And from a pediatrician standpoint, undoubtedly, we've been exposed to lots of coronaviruses in our practice. So perhaps we've been afforded some protection against that. So it's really going to be interesting on how these things play out, how the pandemic has affected a lot of this. You mentioned the flu. What we're experiencing right now is really quite extraordinary with flu, and that is we're not seeing any of it. There's another virus that is very common in pediatrics and in children, something called respiratory syncytial virus, or RSV. That is the major cause of respiratory tract infection in infants. Typically, this time of the year, if you walk with me on rounds in the children's hospital in the middle of January, our wards would be full of kids with RSV. We're not seeing any of it, and it's really remarkable. And what it points to is the natural experiment we've done. In other words, that we've changed our behavior, and nature is giving us the answer. And the sense is that these other viruses have really disappeared. So it really suggests that wearing a mask, washing our hands, social distancing really works. And if somebody says, well, we still have a lot of COVID out there, well, we may have had a lot more COVID if we weren't doing this. So, we're learning a lot of lessons, not only about COVID, we're learning lessons about epidemiology of these other respiratory viruses. We're learning lessons about public health and other safety measures. We're learning a lot about this. And hopefully this will not only help us through this pandemic, but potentially future pandemics.
Yeah, that's great. And that's glad it confirms some optimism I have in the years ahead on the public health front there. Another, question that's kind of, I think a tough one to figure out is, why do some people get so sick and have such a severe challenge with this virus while others have very mild symptoms and none at all? Obviously, age and health play a factor, but there's even significant differences among younger and healthier people. Even myself, who had 2 weeks of symptoms, and my wife, who had absolutely nothing. She teaches young children, so maybe her coronavirus exposure could have played a factor in there. But what do we know there about seemingly some of these mysterious variables that really can't be explained by age or comorbidities?
So this is a fundamental question in infectious diseases and immunity. And it's not just true for COVID, by the way. If you look at flu, if you look at other viruses, chickenpox, if you look at measles, if you went back to look at polio, think about this with polio. Everybody during the pandemics of polio, or the epidemics of polio, there was paralysis that was the result of infection. But later on, we learned that it was only about 1 in 150 people who got infected developed paralysis. So we don't know the answer to this question. Clearly, there's some genetic component to this. We don't know, in some very small realms, we know what the genetic component is for certain pathogens, but for the most part, we don't know this. And I suspect that in the years to come, we may have personalized medicine when we understand the genetics and genomics of this, where we can point to individuals and say, well, based on your genetics, you're at risk for severe disease, and but your mate or your companion or your kid is not. And so we're going to focus on you, keeping you safe, because the others already have the inbred immunity or protection. But this is really a fundamental question. We just don't know the answers to this right now.
Yeah. So regarding regarding masks, I mean, they obviously offer a benefit here, and unfortunately, been the subject of a lot of controversy, and don't want to get into the politics of that. I'd rather stick to the science here. So you see all sorts of masks out there, all sorts of different kinds, many of which are not covering the nose or the mouth at the same time, which is of course another issue. So uh, what data supports the role of masks? And to Doug Bowerman's question, which type of masks offer the best protection when you have to be out and about?
Right. So you're right. There's been a lot of controversy, and I'm not going to delve into that. We know masks work. Not all masks are created equal, of course. Um, and the sort of the gold standard for masks are something called the N95 masks, and that now they are readily available. Um, in fact, if you there are fit testing, of course, it's got to fit properly, and there are ways to make sure that it's fitted properly. But these masks really, really work. And if you want to know the proof for that, just walk into any hospital. So, even though children tend to get less severe disease than adults, we have a lot of kids being admitted with COVID. A lot of their families got COVID, and they're in the hospital. And my colleagues and I have been wearing masks, and for the most part, we've been protected. I think that the big burden on healthcare providers was early in the pandemic when the masks and personal protective equipment was scarce. You saw the pictures from New York of people wearing garbage bags to protect them. But we know that masks work. Again, the gold standard for a mask is the N95 mask. The standard surgical masks actually work quite well too. Again, you have to cover the nose and the mouth. And now there are all kinds of things out there. But if you really want to just a simple test to do is when you put your mask on, blow as hard as you can at your hand that's right in front of your face. If you can feel your breath, that's not a very good mask. And we're all getting accustomed to wearing masks, and they are clunky at times, but they do work, and they work very, very well. You go to the COVID wards, and people are wearing masks, and for the most part, they've been protected. The number of healthcare providers, at least on campus here, who have been documented infection that was acquired through patient care is really, really small compared to all the interactions when you think about between healthcare providers and infected patients. And it speaks to the fact that these masks really work.
Yeah, that's extraordinary because of the constant exposure that they get in the work environment. And by the way, I mean, our sincere appreciation for all of those healthcare heroes that are right there on the front lines. I know you and everybody are playing a role there, but the clinicians that are treating these patients and learning more every day and keeping them alive are truly heroes, and deserve the most profound and sincere appreciation. We as home builders in the audience, and I don't know if you know the answer to this, we're trying to seek it too, but is there anything that building operators or home builders may be able to consider doing to make indoor spaces less prone to viral transmission?
So a lot of this has to do with circulation of the air, right? And a lot more about HEPA filters and air conditioning units and so on and so forth. But we know that if you can improve the circulation of the air, then you're really dramatically decreasing the spread of the virus. And there are many data to support that particular observation. We know that being outside, of course, is much safer than being inside because of the large volume of air. We also learned a lot of lessons about the transmission of pathogens, not just SARS-CoV-2, but the transmission of pathogens on airlines. In fact, airlines are pretty safe because the air that circulates in an airline, in a plane, is HEPA filtered. It's been that way for many, many years. And if you're not sitting next to an infected individual who's shedding a lot of pathogen, your chance of getting infected are very, very small. And particularly now, everyone's wearing a mask, and I would also strongly emphasize wearing eye protection, not just glasses, but maybe glasses that sort of wrap around to protect your eyes, because you can get infected through the eyes as well. So if you're in small spaces and you're during your activities, your work activities, try to get the air circulating. Certainly get an N95 mask, wear eye protection, and of course hand washing as much as possible, and be very mindful of the types of things that you touch and common areas and so on and so forth. So if there's a common piece of equipment that a lot of people are touching, or something in the structure that a lot of people are, a doorknob that people are going through, you may want to think about cleaning that area or that particular piece of equipment, wearing gloves, washing hands. These alcohol scrubs are very, very effective in neutralizing virus.
Yeah. Well, that's great. I know our association here has gotten several thousand gallons of hand sanitizer out onto job sites. And for those of you here, we've still got more, as well as the N95, KN95 masks, which are a bit different, but they're still effective. So if you need those, you can go to our DallasBuilders.org page or talk to Misty. Switching gears a bit, I've got a couple questions related to vaccine uptake, and maybe we'll get to overcoming some of the hesitancy that's out there in the community too. One of the toughest decisions that policymakers advised by health professionals have to make is prioritizing who gets the shot first. What do you think is the right approach here, and what can be done or is being done to increase the uptake now for people who really want it and need it, but also going forward to those who may be more hesitant to take these vaccines?
So I think we all appreciate that the rollout of the vaccine here in Texas and elsewhere has been less than ideal. It's been very clunky. We've got mixed messages, and we're in a situation now where we're trying to distribute vaccine. The last time we've had mass immunizations to this scale was probably in the 1950s, early 1960s during the polio epidemics.
Mm-hmm.
Yeah. So we're not good at this. We're getting a little bit better at this. And now you could see that there are some pharmacies that have it, some pharmacies that don't. Hospitals have it, some of them run out. They have to keep enough stock for the second dose, so on and so forth. So it's been sort of a logistical nightmare. And hopefully we'll get this sorted out soon. Of course, the question is whether we have enough vaccine for everybody. But that in and of itself isn't satisfactory. You have to get vaccine into everybody, or at least for the most part, into a lot of people. So I suspect that now the rate limiting step, if you will, is the logistics of lining people up and start giving injections. That's one major area that's got to be tackled here. Of course, the other big thing that we have to keep in mind is right now these vaccines are really only approved for adults. Yes, the Pfizer vaccine goes down to 16 years of age and older. But eventually we're going to have to start immunizing children, because if we don't, then we're just going to have continued circulation of the virus. We're never going to reach herd immunity, if you will, if we don't get kids immunized. And there are clinical trials right now, particularly with the two mRNA vaccines, looking at children specifically. So right now with the stages, let's get the information out there. As far as people who are hesitant, I understand that. Listen, this is a new vaccine, it's a new platform, and the clinical trials had 20,000 people who got the vaccine in each of the trials. That's a relatively small number, but now the vaccine's going into millions of people. And if there's a safety concern, we'll probably start to recognize it. And other than this allergic reaction, which I showed is quite unusual, we haven't seen a big safety issue. But the bottom line is that anybody who's considering the vaccine, you have to weigh the risks and the benefits. What's the benefit of the vaccine versus what's the risk? The risk, I think, is small. The benefit is huge. Or to look at it a different way, what's the risk of getting the vaccine versus the risk of getting COVID? We know that about 2/3 of the people who are hospitalized with COVID are under 65 years of age. 2/3. We know that about 1/3 of the people who are hospitalized for COVID have no underlying risk factors. So think about that when you're considering the vaccine. Um, but I think for those who are hesitant, I think they'll feel more and more comfortable as time goes on. And I suspect that we'll have a, once the logistics are worked out, we'll have a robust uptake of vaccine.
Yeah. Well, and that's good. And, I know we'll have the 1 in 20,000 things were revealed in the trial, but the 1 in a million, 1 in 10 million, 1 in 100 million are concerns. But, at the same time, we'll get some more data as well. I know, my sister who's 8 months pregnant is looking for a little bit more information on the impact of pregnancy and lactating. And my father, who's 65 and has several comorbidities, will go to the ends of the earth to get the vaccine. So it just kind of illustrates the interest there. Another thing that I've seen in the United Kingdom, and it was considered here for a little bit, is, and this goes to some of the questions that I see on here, is changing the doses or lengthening the time frame between the two shots. I don't see the data there. I personally would be concerned about that, but I wanted to hear your thoughts on changing that or mixing two different vaccines, two different platforms, things like that. Your observations and thoughts on the prudency of even considering those strategies.
I don't think there's any consideration to change the potency of the dose for the second shot. There's been some chatter out there about that, but realistically, that's not going to happen. I mean, first of all, the FDA won't allow it, because to do that, you'd have to have a clinical trial. So I don't think that the potency is going to be an issue. Of course, we have this 21-day interval for Pfizer, 28 for Moderna. These are, well, somewhat arbitrary. We know that for vaccines in general, to get that booster effect, you typically have to get it at least 3 weeks after your initial dose. And this is not, we know this from other vaccines, and that's why this interval was chosen. So my recommendation would be, you don't want to get it sooner than 21 days, but certainly you can get it later than the 28 days for the Moderna or even the Pfizer. In fact, the CDC and the FDA state that if you're late getting your second dose, go ahead and get your second dose. It should be the same one you got in your first dose, same vaccine. And there's no need to repeat it after that. In other words, even if there are months that go by between first dose and second dose, I'm not recommending you should do this, but even if that's the circumstance, you don't have to start the series again. And we know this from other vaccines. We know a lot about the immune system and how it responds to vaccines. So that booster dose is going to be very effective. We know that for the Pfizer vaccine, and to some extent the Moderna vaccine, one dose afforded about 50% protection, although the numbers were pretty small. So it really shows that you do need that second dose. And again, get the second dose. Try not to mix up the two vaccines. Of course, there are going to be people who do that, and we simply don't have data on that.
Yeah. Well, we're 4 minutes to the top of the hour here, so I want to kind of look forward with this last question. And it seems like where we are now is a bit of an arms race between the vaccine uptake and trying to get, you mentioned that last mile, that last inch into the arms that need to have them, versus the virus that's still raging like a forest fire through the population and the different variants that may be accelerating that through. What's your prognosis for the rest of this year? If you had a crystal ball on, when we could expect some semblance of normalcy, and then when ultimately could we put the pandemic behind us, of course, realizing that SARS-CoV-2 will be endemic probably for the rest of our lifetimes, if not longer. So just mainly your thoughts on the rest of this year and what we could look forward to.
I'm always hesitant to make predictions, but I would say that as the vaccine becomes, the use of the vaccine becomes widespread, we may see a change in the arc of the pandemic. In other words, I showed you on the earlier slides, we have the second wave, and we don't know if we reached the peak yet. And maybe there are some places in the country where they've reached the peak. We don't know that, of course, until there's another peak. But to address this, I think, maybe by late spring, early summer, we'll start seeing a dramatic decline in the virus. Again, we have to get kids immunized to really put a big damper on the virus. Maybe by the fall, we'll get back to whatever normal looks like again. I don't think we're going to go back to what it was like pre-COVID. I guess the question is, when are we all going to feel comfortable going out to a restaurant without a mask on, or when we're allowed to do that? And maybe spring, maybe summer, late summer, fall. These variants are the wild card here, and these variants can arise. And we have 4 examples already. They arise spontaneously. And we don't know whether they're going to be more lethal. We don't know whether they'll be more easily transmitted, even compared to the ones that are out there right now. So the variants are the wild card. And of course, how the vaccine protects against the variants. So that's a big concern. And if a variant were to emerge that seems to be resistant to the immunity, or at least relatively resistant to the immunity induced by the vaccine, that's going to set us back quite a bit. So tough to say right now, but I'm looking for the encouraging signs right now, and I'm not seeing many of them. But hopefully, again, the arc of this pandemic will start to change in a favorable direction, and that will make me more comfortable for my predictions for late summer, early fall.
Yeah, I hope so as well, and also fear the challenges of when the virus is faced with a large section of the population that's vaccinated, will have more evolutionary pressure to perhaps try to find its way around them, and it also speaks to the need to get these vaccines into the arm of the rest of the world too, because of how connected our society is. Well, we are right at the top of the hour. Dr. Kahn, again, thank you very much for lending your time to us, you and your team at UT Southwestern, and all of our healthcare heroes that are keeping us safe, treating our loved ones, and helping us get through this crisis. Again, thank you for your time. We really appreciate it.
My pleasure.
All right. Take care, and thank you all for joining us and for your questions as well. Have a good morning.
All right. Bye now.